Hello, everybody. Let's get started for the day 7 of CS47. So we supposed to start, already started about that simulator setup, IDE, and have a little bit hands-on on the assembly programming on the MIPS platform. Any question, difficulties that you have, you might want to bring now? No? Okay, there is no question to discussion as well. Well, let me first try to explain one thing. I often find that students are not very clear about the system call usage and what to do about that. Um, with that respect, let me try to explain through the sample example that we did for this lecture for that small MIPS program that prints the answer is 5, that thing. Um, so screen, okay. So this is the Mars. This is the Mars that IDE basically that you can bring up. Let me just make it bigger slightly. Okay. And here what your program you are writing, and you are writing a data section starting with the dot data, where you are defining all the constants in your program. Basically, you can think that way in the high level programming sense. And each of this level, you can consider them as a high level variable. Though internally, these levels indicates an address, And then we start with a text section, and text section goes with some simple system call with the 4, 1, and then system call 10. So how it works? So some student, I have found in every semester, some student thinks that, hey, syscall, like every instruction I'm writing, I need to have a syscall so that it execute the previous instruction. It is not. Syscall is an instruction by itself. And what it does, it basically, when you send this instruction to the system, then it looks for the value in the register. Let's call it a variable. So we haven't yet talked about the register, that concept. Yes, let's talk about the variable. V0, it looks value into the V0 and see what the value it is. And then depending on that, it takes the action, right? So here, for example, let's pick up this example, right? Or let's do it this way. So we write a syscall. And by the way, syscall is not a MIPS assembly instruction at all. It is just an made up instruction given by this IDE and spin simulator system to make an easy IO, like input output, like printf and scanf kind of functionality. That's what it provides. Syscall is not a real MIPS instruction at all. And now when it finds a syscall, this instruction tries to find what is in V0. So what is V0? Let's for timing assume there are some predefined variables for you to use. V0 is one of them. Later in the next lecture, you will see V0 is nothing but one of the register or storage element that is referred as a name $V0. Okay, but for timing, let's say there is some predefined variable for you, and the one of them is $V0. So this guy looks looks into this variable and ask what is the value, right? And then there are some predefined code which is given. I think I have included this one in your canvas somewhere, this table. So it looks for the system called code, like this one. This looks for V0 into the V0. What is the value? So for example, here we are putting the value 4 into the V0. So LI stands for load immediate, which is a pseudo instruction, but it mainly means that whatever you are writing the value here as an integer value, it will be stored in that target so-called variable. I'm still using the term variable, but they are the register. So it loads the value V0. So essentially what it makes V0 value is 4. Now syscall looks that variable, see that its value is 4, and it knows that, hey, I need to do a print string, okay? And where is that string? As we know, strings are always, and like these strings are series of ASCII code of the entire sentences, ASCII code of each character comprising the sentence till a null character. So it starts from an address, okay, address in the memory. So it looks for that address in register A0, or for you right now it is a variable A0. So we involve another term A0 there. So what is happening here? Now let's assemble this program and take a look. So if you see, okay. When you are, first of all, when you are writing this statement dot ASCII Z with the lower is A equals A, let me stop my video, okay. And this is a string. So corresponding each character has the ASCII value, and it will be stored from somewhere. Where? In this example, it starts from this address. So look at this label, the symbol table. It says that str is at some address, memory address. And where is that address? If you double click that, it will actually show you here, right? This is the double click. And you see there are some hex values. Remember, the hex values are what? Hex values are nothing but binary representation of 4-bit each. Each of these hex digit is 4-bit binaries. So you see there, if you count it, it becomes like 1, 2, 3, 4, 5, 6, 7, 8. 8 of the hex characters, the digits are there. That means it is total 32 bits. And then you can actually see, divide them into 8-bit each, and each of the 8-bit becomes a ASCII code value. In fact, if you click on this one, you can see the representation of that sentence. The answer space is equal into here in the memory that laid out by the assembler. So THE space ANSWER space I S equal S space equal. Now, why it is like this sequence? Why don't we just see the sentence like this straight way? It is basically giving you values from lower address, like it's starting from 1001 0000. Then this is that part 1001. Okay, so this is your starting of the string, and it goes in an increasing order this way. So this is position 1, then it is position 2, then position 3, then position 4, then position 5, and so on and so forth. We'll study more about this memory layout and how the data are laid out onto the memory, what sequence, etc. It will come up in 2-3 lecture down the line. But right now, just assume there is certain rule that assembler follows and put your ASCII code onto the memory in certain sequence. And ultimately, they're not an alphabet or a character, they're practically a representation of characters only, nothing else. Uh, and they are stored as values in the memory. All right. Questions so far? Anyone with any question?
Are we going to be using the emulator or the simulator today in the lecture?
Yeah, we can use it, definitely. So you're looking for anything specific?
Everything sounds so far so good.
Okay, all right. Now it comes to, now let's start executing them, right? So let's say, let's step through. Like this is a run one step at a time. So what it does, you see that you step one, okay? And then you see the V0, that we call it a register. It is there, all the predefined variables for you. For time being, you assume that. They change to the value 4. So we are storing the value 4 over this V0. Okay, and by the way, this value represented also in the hex. Okay, anything leading with 0x is the hex. Then this is li, and you see the li has been changed to some basic functionality with something called add IU, add immediate unsigned. So that's why it is a pseudocode. It is not really the code like instruction that MIPS understand. It's basically the assembler provided pseudocode that helps you to write code faster. Okay, now on to the next instruction. Similarly, you see that LA, load address. So the target of the load address is really to, so when you are doing a str, you are referring to the some label. So li is basically referring to some values. LA should refer to a label. And what does it mean? It means that load the address belongs to this str, or load the address assigned to this label onto this variable. Okay, so that's what it means. So this is what it does then. This is what it does is, go one step, it does change something like $1, which is assembler temporary, okay, some variable 10010, and or with 0. So at the end of the day, when this one is done, your A0 is loaded with the address of that label str. See, so your V0 is 4, A0 is label str, and now you are invoking, syscall. So syscall now go and check the content of the V0. It goes and checks, hey, V0 is 4. That means it user wants to print some string from an starting from an address. And what is that start address? It should look into A0. So these are all fixed convention for the syscall according to this table. So if it is 0, your argument needs to be on the A0. You cannot put it anywhere else. Okay. So given that, then you do the syscall step 1, and you see this, run IO. This is printed. The answer is equal, right? And then going forward, you are changing now V0 value to 1. Now 1 is what? 1 is syscall for printing an integer, where the integer value is given in the A0. Okay, So now V0 is at 1, and now next instruction will give us A0 at 5, and now we are calling syscall. So syscall is now going to look at V0 value. Oh, hey, this is 1. So according to this table, I need to print integer from the A0, $A0. So what is $A0? It's 5. So it will print the 5 here. And similarly, next step, I'm loading the next syscall, which is hex A, which is for exit, and syscall will terminate the program onto that syscall. So that is the fundamental function of the syscall, to provide a basic operation, IO operation capability to the simulator user. This is nothing specific to the MIPS processor at all. MIPS processor, this is not a MIPS processor instruction. Question? Okay, so let's look at this table now in a little more detail. So we already have seen print int, print string. Now interesting would be the other way. If we want user to type in something, which is read int, so its syscall is 5. There is no argument associated. That means you need to set only the V0. So your V0 should be should be 5, and then you do the syscall. So syscall, what it will do, it will wait in your IO terminal for user to type in something, some values, and as soon as user hits return, that value will appear on the V0 itself. Okay, so V0 will be changed. So V0, you are storing V0 with 5, call the syscall. Syscall knows this is redeemed. It will wait on the IO terminal for user to type in something and enter some values and enter, and it will capture that value onto the register V0 itself. Then after that, you can transfer the value from V0 to some other variables, register, etc., etc. And then the other interesting would be the exit. We already done that. Another would be print character instead of string is the character. For this one, your V0 code would be 11, and you load the character's ASCII code value onto the A0. That's why you can print one single character. And similarly, read character has another system called code 12, but here you need to make sure you look at carefully at where it is returning the character. It is in the A0. Unlike the read int, it returns in the V0. Read char returns the typed ASCII code onto the A0. Question? Okay, then if we don't have any, so I believe there would be a programming assignment 1 published tonight after the class, and it is due next day. Let me look at the schedule. So your programming assignment would be coming tonight, due on February 23. Another programming assignment will be due on February 25, which will be published on February 23. So make sure you are up to date with your assignments and your study on your assembly coding.
Wait, Professor?
Yes, Rahul?
So coming Tuesday, we are going to have the quiz and the programming assignment.
Quiz is this Friday and Saturday,
Oh, all right.
right? And yeah, 18, 19, I think. Yeah, 19, 20. And then programming assignment would be due on the February 23.
I see. Okay. Thank you.
Okay. Now, why don't we do a little bit of problem now? So let's see. Hey, where is my Jamboard? Okay. Okay. All right. Now you can also go to the Jamboard, class Jamboard, and see the problem. Just let me load it first. Okay, so let's say we have given a problem like this, some code, some assembly code, and you need to fill out a symbol table, okay, like this. Okay, and a problem statement. So this one is your first problem, let's say. And there is another problem. Let me put two problems together. Let's say there is a macro like this. And I have some macro usage. I have another macro, let's say. Okay, now let me share. Okay, so here are the problems. Number one is that you have given a program like this, okay, like this, and you need to fill out the symbol table, address being with the relative address, means you basically first instruction addressing being 1 and so on and so forth. So you start with a 1. There is no real address need to be considered at this point. So you need to fill out this table. That is the first problem. And second problem would be this. So let's say I have macros like the following, like these two. And for these two macro definition, expand the macro call, okay, and write down the expanded text from, like, let's say I'm using like my para, I'm passing the values like Frank and these, etc., etc. So what would be the ultimately expanded text on replaced at that macro call used in the assembly program? So that is the second problem. So let's see, what's the time now? 6:25. Let's take 15 minutes. I'm opening up the breakout room for all of you. Let me make sure I open the share screen so that you can share screen among each other. Use the Google collaboration docs to maybe to collaborate among yourself, and take 15 minutes, 6:25, 6:40. We'll be back. So option 15 minutes, 10 minutes. Okay, now I'm opening. Okay, let me see. Hello, Dominic. Do you remember which group you are in?
Hello.
Hello, Dominic.
No, I do not. Let me check. Sorry, I was reading. I was having problems loading in Zoom, and then I tried to join during right now.
Yeah, so there is a canvas. So I have assigned some study group. So do you remember which study group you're in? I can check for you. You are in study group 6. So let me send you to study group 6. Okay, let's wait for a couple of more seconds to everyone to come back to this main session while I need to resume the recording. Okay, I think everyone is back. Why don't I turn to study group 5? What's your outcome so far? Ekta Halani, Patricia Zoe, Chirag Kundan. Want to share?
We didn't know how to solve it.
Okay, so anything you discussed along the way? Okay, then let me turn to, how about study group 2? Kevin Grewal, Artyom, Harsh Singh.
I wasn't able to find the addresses.
Okay, how about the other problem?
What was that?
So did you guys do any of this problem or just number 1?
I was stuck on number 2.
Number 2? Okay, how about number 1? Did you attempt this to do that?
Yeah.
Okay. So how about, do you want to share what's your finding or discussion you did?
I said the label was loop L1 and L2.
Okay. And how about the relative addresses?
Loop begins at the first LW, so it's at 0x0.
Okay.
And then L1 is at addition, also at 0x0.
Mm-hmm.
And then for L2, it was the push addition at 0xFFFFF.
Okay. Okay. Not really correct on the address side. Level side, yeah, you are right. There are 3 loop L1 and L2, but others are not. So we'll see. Let me see if anyone. Okay. Any other group wants to volunteer?
Can I try, Professor?
Yes, Ricky, which group you are?
3.
S3. Okay.
So I'm not too sure if these addresses are correct, but for loop, I got 6, L1 14, and L2 16.
I think, yeah, you guys are correct. Yeah, that's good. So what did you do? What was your thinking process there?
So first we looked for the labels, which were loop L1 and L2.
Mhm.
Then we looked for the first line of instruction that corresponds with it. So for loop, since the line directly across from it is a comment, that's not actually an instruction. So we moved on to the instruction after it, which is LW R5 R2 0x0. And
Okay.
then for the other labels, we just counted down the instructions until we found the next instruction that came after L1, and same thing for L2.
Right, exactly. You followed the right way to do that. Okay. Any volunteer for number 2? Any study group other than SG3 who just did answer for number 1?
Can I try?
Okay, Rahul, which group you are in?
I don't know. How do I check my group number?
Okay, I think you are in study group 2. The one I put you in the breakout room.
I see. Okay. Yeah, I don't remember checking what my breakout room number was.
Oh, yeah.
All right. Uh, so there are two macros. There's a nested macro in it. I first expanded the inner one and then I expanded the outer one.
Hmm?
And the final statement that the final paragraph that I got is, I am Frank, comma, born on 28th September 28th Sep 2085, comma, new line. Therefore, I am a computer guru, new line, and my ID is Frank underscore 28th Sep 2085. New line, I am 30 years old and love to eat pizza.
Yeah, exactly. Thank you very much now. Okay. So,
Thank you.
okay, why don't we take a 5-minute break? 6:52-ish, 5-ish, we'll be back. Hey, let's resume our session. Why don't I just start with that poll of how prepared you are for this class. Let's say I'm launching the poll. Just take a couple of seconds to do that. You can take it anonymously, probably. Maybe, yeah. 17 of 20, 18 of 20. I'll wait probably a couple of more seconds before I close the poll. Okay, let me share the result with the class. So have you watched the lecture videos and read lecture notes for today's topic? 61% said all of them, 28% said some of them, 2 of you said none of them. For those two, please make sure you read before you come to the class. Otherwise, the discussion will be just over your head. You won't get head and tail of the discussion that we are making here in the class. All right, it is very important. And second is, have you noted your queries in corresponding discussion page? One said yes. I don't remember to see any question there. But anyway, no means you have query, but you didn't add that in the page. I hope you will be asking in the class, though I haven't got many questions in the class. And I don't have any question, 5 of you. Yeah, please make sure you raise questions. This is a very important for a critical study, that when you study, you try to understand some aspect of a topic. It must generate queries within you. Like that's how we learn and advance. All right. Okay, now let me try to solve those two problems, explain those two problems for all of you to make sure everyone is on the same page. Before I go there, any question for me? No. Okay, then let's get back to our whiteboard. And so the problem, we start as a building of the symbol table as assembler does is, first of all, let's put down the line numbers for each of the code. Why I'm putting down the line number? Because like some of you actually mix up instruction number with the line number. So just to explain that, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Now, see, this given program has 23 lines, but it does not mean it has 23 instructions. It has, if we count the instruction one by one, this is the first instruction, this is instruction 2, this is instruction 3, 4, 5, 6, 7. So instruction number necessarily does not correspond to the line number. So let's write down the instruction number. This is 1, this is 2, this is 3, this is 4. 5 doesn't have, 6 has instruction 5, and then 7 doesn't have any because a label is not an instruction. Okay, label is not an instruction. So this line has a label followed by a comment, so there is no instruction there. Then we have number 6 here, 7 here, 8, 9, 10, 11, 12, 13. Then we have the blank, and then label at the line 17, then another blank. So line 19 actually has one real instruction, which is instruction number 14, then 15, then 16, then 17, then 18. Now, the symbol table construction, the way assembler does it, let me explain, and at the same time, let me also explain this concept of the forward referencing. So assembler goes through this line by line, right? And then it hits a line which has a label, and it sees that this label is not in the symbol table. So what it does, it basically note down the label entry there, and then it keeps on scanning, and whatever the next instruction, immediate next instruction is, it associates that instruction number with that label, which means for this example, your loop is associated, the nearest next instruction is this, right? And similarly for the L1, nearest next instruction is this. And for L2, nearest next instruction is this one. So this guy sees that, okay, this is the loop is nearest next instruction is number 6. So it put 6 here, and then it scans through these, keep on scanning, etc. Now, let's say it is scanning this guy. You see there is a reference to a label, L1, reference to a label. Now at this point, assembler consult this table and see there is nothing called L1, so it cannot resolve the code belongs to this instruction. So this condition is the forward referencing. So L1 is one of the forward referencing because L1 is used at this point in instruction 10, but it is not defined yet in the program. So this is forward referencing. Now going forward, then it scan next one, boom, here it reference to another level 2, which is not there in the reference table. So this is another forward example of the forward reference, because L2 is not yet an entry to the symbol table. So it is not there. So this is a forward reference. Then going forward, it keeps on scanning the lines, and then it hits a level L1. So it enters L1 there, and as soon as it hits the next immediate instruction, it note down that corresponding instruction number for that level. So L1 relative address become 14. And then it goes on doing this, and then next line it sees there is an L2 level, so gives enter there, and then it scans the next instruction, which is this one, and it says, okay, this next instruction is referring to instruction number 16, and it goes there, it keeps on scanning, and here it had hit another reference to another level called loop, but loop is already in the symbol table. So at this point, this is not a forward reference. This is not a forward reference. So in this program, you have 2 forward references, and this is how your symbol table with a relative address. Once we study about the real memory address and all the stuff, we'll learn about what the real address would be here. But let's start with the concept with the relative address, which is nothing but your instruction, corresponding instruction number. Question?
So for the labels, do they account for all the instructions that come after until the very next label, or?
Come again? I didn't fully get you.
So the label starts at instruction 6. So does that mean it basically accounts for all the code from instruction 6 to instruction 13? I'm not really sure how like labels work yet.
Oh, okay. So label is basically a reference to an address. So it does not like contain a code, or it does not do anything. It's just an easy reference to an address that you may refer in your program. For example, if you look at this code, right? Jump L2.
Yeah.
So this is what it is saying, that instead of computing what the real address of this instruction would be in the memory, remember, like we discussed, that program machine code goes into the memory and picked
Yeah.
up from there, right? So you are referring to an instruction by its address. So here you want to do jump to L2 really means next instruction you need to execute this. Okay.
Oh, I see.
For BNE, this instruction really means compare these two variables value or register values. And if they are not equal, then a next instruction to be executed is this one, which belongs to some address. Now question become how you define or have that address, refer to that address. That's why you are giving name to an addresses. Okay, so in this address becomes like is assigned with, sorry, these labels are assigned with some addresses which belongs to the immediate next instruction.
Oh, I see. I see.
Okay, so for example, I can elaborate it with this one, screen one, share. Okay, let's say, let's try to put some labels. L1. Okay, and then let's try to do a jump L1. Okay, let's assemble. Now you see that I have now two labels. One is str1, which is coming from the data. Another is L1, just we defined L1 right here, right? So L1 has an address value of 00400C, which is, if you double click, which is an address of the syscall, right? This instruction, right? So whenever you are actually referring here, let me note it. Referring here, this L1, you are basically telling that jump to the instruction at address belongs to L1. So jump to the instruction at address 00400C, which is here. So that's the real meaning of this label, that it belongs to an address, which can be either corresponding to an instruction code or corresponding to a data. For example, str, that label is corresponding to a data. We are referring here st1 corresponding to the data level str. Make sense, Kevin?
Yeah. Thank you, Professor.
Anyone, any other question from anyone on this?
Professor,
Yes, Andrew?
I'm still a little confused as
Mhm.
when the when it, so for example B and E R8 R9 and then L1.
Mhm.
So the first time you go through, it doesn't have the label in the symbol table yet,
Mhm.
right?
Mhm.
So then when does it puts that instruction on hold until it can find the address for L1?
That's why like there is this two pass assembly. The first pass is
Oh, okay, yeah, two pass.
yeah.
Okay.
construct the symbol table, and second pass, then it start creating the machine code for each instruction. And whenever there is a reference to the label, it consult the symbol table, pick up the address value and combine that for that instruction.
Okay. So the first pass is just for looking for labels and creating symbol tables.
Right, exactly.
And then the second pass is when they actually begin generating machine code for all the instructions.
Exactly, yes.
Okay, cool. Thank you.
All right. Okay, now on to the next one is this one, right? Expansion. This is very simple. So we start any expansion, like any macro expansion when we use in the assembly program. First, the assembler does is to first expand that macro and then try to assemble it, okay? So we are calling with the Frank these 4 arguments for that macro. And by the way, when I call like arguments, usually students associate that with a function call. This is not a function call. This is macro is just a blind text expansion. Okay, so we are just replacing this $name with Frank, date $date with this value, 28 September 2085, $age with 30, and food with pizza. And then it start expanding. So first thing it does, it sees this is another macro call. So it refers to that macro, which means this name already replaced by Frank. So that means this name goes as a Frank and date. So it is kind of a sequence, not sequencing. It is in reference to that variable name, name, date, etc. So date, this date corresponds here. So that means this one goes there. So date is this. So it first expand this macro, which becomes like pretty much starting with this first letter I am. Now it refers to the $name. $name is what? Frank. So it replaced $name with Frank. Born on. Now $date refers to 28 SEP 2085. Then it followed by the new line. Followed by a comma, then new line. So it expanded like that. Therefore, I am a computer guru. Then new line, and my ID is, then it is referring $name underscore $date. The $name will be replaced with Frank, and then underscore, then $date will be replaced with that date string, 28 SEP. So it is practically a blind text substitution, followed by, oh, there is the end of the macro. So we are end of the macro. Now we are done with the expansion of this macro. Then the original my para macro extraction goes on. I am now $age replaced with 30 year old and love to eat. $food replaced by pizza and end. So that's what is expanded with this macro call. It's obviously is not a assembly code, and definitely if you want to assemble it, assembler will give you an error, but nonetheless your macro expansion will work. Okay, it will blindly expand whatever you're writing there. Question? Okay, 2 minutes. Let's quickly look what is upcoming for the next lecture. So we are done with the module 2. We started the basic programming, and then we are going to the module 3. So please visit the introductory page of the module 3. It will establish the baseline of this module, what is targeted, etc. Please watch this video and then come back to the memory usage 1. So in this module, we are going to study about memory usage, how to use different storage like registered file and the real memories, and we'll discuss around that. Very intense, by the way. Please make sure you focus on this study and grasp the concept there. Memory usage 1 is a little bit on the easier side. So we talked about the registers, right? And there we go with the concept of the registers, what are they? And then we talked about the register file. And here, make sure we have one little bit off the convention than what the book says. This is about usage of this guy. On the book list, you'll see it is no, preserved across the call no. We say yes, but this is not yet important. This will be relevant in our function study, like how we can build a functionality of function in the assembly code. So this will be relevant, but take a note, this convention is different than what your book says. Okay, so we follow this convention in this class of preserve this value across the function call or not. That's the one thing to note here. Now, from there, we'll look an example program, how we can store and retrieve value from the registers, how we can refer to the registers with the numbers and by its name or number. We'll do different experiment around that. Please make sure you complete those experiments. And we'll also study about the convention of the register usage. For example, for your user program, you should not program K0, K1, you should not use it, you should not use 80, etc. So we discuss all of this in these lectures. And then we talked about some special register called high register and low register, and how to access them with a specific specialized instruction called MF high, MF low, and MT high, MT low. We'll do about that. Then we'll do some experiment, which is actually programming assignment 2. So you need to complete that assignment as well in 1 day. After, I think it is due on 25th, probably. Then we'll talk about the Louis experiment, which is nothing but your programming assignment 3. Please make sure you follow through that one as well. So this is all about register usage and how we can combine different value, how we can access them, how we can use them, etc. It has quite some videos, especially this is important, programming assignment 2-3 discussion, very important discussion. Make sure you pick up on that one. And other than that, these are like, okay, this is a little bit longer video of BIPs register because it's more talk about the convention of registers and the usage of the registers. And then we demonstrate about the register experiment and data movement, etc. So make sure you go through the video, very important concept, and pick up the concept right up front. Don't procrastinate on that. Okay, we are 2 minutes overboard the time. If we don't have any other question, let's say good night tonight and see you on next week.
Thank you, Professor.
Thank you, Professor.